Imagine you're just opening WhatsApp
Right.
to text your family, right?
Just a totally normal daily routine.
Yeah, exactly.
Yeah.
But instead of just texting, you end up getting world-class clinical medical triage, completely for free.
It's wild to even think about.
Or, you put on your smart glasses, and they instantly decode this massive, complex manual right in front of your eyes.
Right, just natively understanding the physical world.
So, welcome to all of you listening out there, because we are looking at a fundamental shift today. Meta just dropped a product that might literally turn the social media apps you use every single day into the most powerful reasoning engines on Earth.
It really is a defining moment for the industry. I mean, the era of Meta just sort of playing catch up to the rest of the pack, that seems to be officially over.
Yeah, they're not playing around anymore.
Not at all. They are placing a very high-stakes, multi-billion-dollar bet here. And trust me, every single competitor is on high alert right now.
Okay, so the product is called Muse Spark, and it's Meta's newly formed Superintelligence Lab's most ambitious release to date.
By far their biggest swing.
Right. So our mission for all of you tuning in is to figure out, does this underlying technology finally close the gap for Meta? Or is this just, extremely expensive hype? Okay, let's unpack this.
So to really grasp the engineering leap of Muse Spark, we actually have to go to slide 2 in the breakdown. We have to contextualize the rather desperate position Meta was in just a few years ago.
Yeah, it wasn't looking great.
No, because this wasn't born out of a comfortable lead, it was born out of an existential threat.
Right. Because for much of the past decade, Meta was essentially just watching from the sidelines. Rivals like Google DeepMind and OpenAI completely defined the frontier of artificial intelligence.
They were writing the rules.
Yeah. Those companies were dominating the benchmark leaderboards.
Right.
They were locking up massive enterprise adoption. And Meta was genuinely struggling to just keep pace with their internal AI division.
What's fascinating here is the sheer scale of the corporate pivot Meta undertook in response. I mean, they didn't just tweak an existing algorithm.
Or just shuffle some executives around.
Exactly. They committed billions of dollars to a ground-up structural overhaul. They essentially dissolved the old way of doing things, spun up the new superintelligence labs, and Muse Spark is the first proprietary flagship to come out of that.
So they shifted from trying to mimic the competition to trying to completely leapfrog them with brute force engineering.
That's exactly it.
But wait, hold on. Let me use an analogy here. It's like a sports franchise that has been losing for a decade, right? So they fire the general manager, restructure the whole front office, and buy a superstar to win the championship immediately.
I like that comparison.
But you can't just throw money at a data center and expect top-tier AI innovation overnight, can you? Does throwing billions of dollars at a structural pivot actually guarantee a mathematically better model? Or are they just buying expensive hardware to run the same old algorithms?
Well, that is the multi-billion-dollar question. Money buys raw compute power, and, it buys elite engineering talent.
Sure.
But synthesizing all of that into a cohesive, world-beating architecture, that is incredibly difficult. You can absolutely fail even with an unlimited budget.
So the money isn't a guarantee.
Right. But what that massive budget allowed them to do was abandon older, retrofitted AI models and just build an entirely new architecture from scratch.
Okay, so that answers the why behind the billions spent. Let's move to slide 3 and talk about what that money actually bought them under the hood, because this is where Muse Spark gets really interesting.
It's a huge technical leap.
The internal document describes it as a natively multimodal reasoning model, and it emphasizes that it's designed from the ground up to perceive and reason across text, images, and voice simultaneously.
Treating them all as first-class citizens.
Right, not just add-ons. Plus, the rollout strategy is massive. It's available right now on meta.ai with no waitlist.
Yeah.
And it's rolling out across their entire social ecosystem: WhatsApp, Instagram, Facebook, Messenger.
And perhaps most crucially for the future of their hardware, it is integrating directly into the physical world via their Ray-Ban smart glasses.
Okay, I want to pause on that phrase, natively multimodal, for a second, because we've had AIs that can look at pictures for a while now.
Sure, vision models aren't entirely new.
Right. But if I understand the engineering correctly, an older, retrofitted AI is sort of clunky. It's like a tourist relying on a translation app.
Oh, that's a good way to frame it.
The AI essentially thinks in text. So when it sees an image, it has to use a separate piece of software to translate the visual data into a text description before it can even begin to process it.
Exactly. There's a middleman.
But Muse Spark doesn't do that. So is a retrofitted AI like that tourist with the translation app, whereas Muse Spark is actually natively trilingual?
That is a phenomenal way to visualize it, yes. A retrofitted model has pipeline latency. It loses nuance and speed in the translation between sight, sound, and text because it's bouncing data between different subprograms.
It's just inherently slower.
Right. But Muse Spark shares a joint embedding space. Its core architecture processes the visual pixels, the audio waveforms, and the text tokens simultaneously.
That is wild.
And if you think about the integration with those Ray-Ban smart glasses, that zero latency reflex is practically mandatory.
Why is that?
Well, when you are walking down the street wearing those glasses, the AI needs to see the traffic you see and hear the sirens you hear in real time without losing context. That seamless, real-world experience is only possible with a natively multimodal architecture.
Oh, wow. Yeah, that makes total sense. Okay, so now that we understand it processes the world natively, let's look at slide 4 to see how it actually thinks and operates.
The engine inside, basically.
Yeah. The documentation details 4 key capabilities that push this way beyond a basic chatbot interface. The first is that multimodal perception we just broke down.
Right.
The second is tool use support. This means the model natively hooks into external APIs. It doesn't just give you instructions on how to do something, it can actively interface with other software to execute real-world tasks on your behalf.
Which is a huge step toward real agency.
Definitely. And the third is visual chain of thought, where it actually provides visual aids to explain its reasoning process.
That one is crucial.
And the fourth is something they're calling contemplating mode, which orchestrates multiple AI agents to solve complex multi-step problems, supposedly rivaling Gemini DeepThink and GPT Pro.
If we connect this to the bigger picture, that third point, visual chain of thought, is a massive leap forward for user trust.
How so?
Historically, interacting with an AI has been interacting with a black box. You feed it a prompt, it spits out an answer, and you have absolutely no idea what logic it used to arrive there.
Right, you just have to blindly trust it.
Exactly. By generating visual maps of its reasoning step by step, Meta is allowing you to audit the logic. If you are going to rely on this system for critical tasks, you really need to trust exactly how it's making decisions.
That makes a lot of sense for building trust. But I want to challenge that fourth capability, contemplating mode.
Okay, let's hear it.
The document claims this rivals GPT Pro. But practically speaking, how is an AI orchestrating multiple agents any different from someone in our audience just typing a really, really detailed prompt into a standard AI and asking it to do 5 things in a row? Isn't it all just following instructions?
It sounds similar, but it represents a fundamental shift in how the compute is applied. When you give a standard AI a long prompt, a single model is essentially playing a game of probability.
Like guessing the next word.
Right. It is trying to predict the next best word to satisfy your entire massive request in one continuous stream. Because it's doing it all at once, it gets easily confused, it hallucinates, or just forgets constraints you gave it in the first paragraph.
Oh, I've definitely had that happen.
Contemplating mode doesn't do that. It acts like a project manager.
So it shifts from being an encyclopedia to being a manager.
Exactly. If you give it a complex problem, say, plan a 2-week itinerary in Tokyo, balancing the strict budget, these dietary restrictions, and cross-reference it with live train schedules, it starts and breaks the problem down.
It delegates.
Yes. It spins up specialized sub-AIs, or agents. One agent goes off to scrape live train schedules. Another agent evaluates restaurant menus for the dietary restrictions. A third handles the budget math.
That is so...
And the main model oversees them. If the budget agent says, hey, this restaurant is too expensive, the main model forces the restaurant agent to go find a new option. It iterates, resolves internal conflicts, and then synthesizes the final answer for you. It is actively thinking and delegating.
That is a totally different paradigm. But of course, claiming to beat Google and OpenAI at complex reasoning is a huge boast. So let's move to slide 5 and look at the actual scoreboard to see if the math matches the hype.
The performance benchmarks are genuinely staggering for a new architecture's first outing. I mean, it's impressive.
Yeah, let's highlight where it's winning. Muse Spark scored a 52 on the Artificial Analysis AI Intelligence Index, which drops it solidly in the top 5 globally right out of the gate.
A very strong debut.
But here's where it gets really interesting. It took the absolute crown as the agentic search leader. It scored a 74.8 on Deep Search QA.
Which is huge.
Yeah, that beats Gemini's 72. It trailed slightly on a vision test called MMMU Pro 80.5, compared to the top rivals, 82.
Close, but not quite there.
Right. But then has secured a massive victory on something called Health Bench Hard, heavily outperforming both GPT 5.4 and Gemini 3.1 Pro.
Let's break down that deep search QA win because it proves the power of that contemplating mode we just discussed.
Okay, tell me more.
Excelling in agentic search means the AI is doing far more than just regurgitating facts from its training data. It is actively hunting.
Like researching on its own.
Exactly. If you ask it a complex research question, it essentially opens virtual browser tabs, clicks on links, reads the content, evaluates if the source is credible, and if the site is garbage, it hits the back button and tries a different query.
Wow, autonomously.
All autonomously before returning your answer. Beating Google at live search, even this specialized agentic search, is a massive validation of the Superintelligence Labs team.
Okay, so it hunts for data like a bloodhound, and it can pass complex medical reasoning tests. But before we crown Meta the undisputed winner, Slide 6 forces us to look at the reality check.
Right, because no model is perfect on its first outing.
Exactly. The internal breakdowns are very clear that this model has some glaring blind spots.
Significant gaps that reveal the limitations of its current design.
Yeah, the breakdown highlights a few key areas where it falls behind. Coding performance on Live Code Bench Pro is close, but trailing 80.0 versus Gemini's 82.9.
A slight miss.
And on certain autonomous workflows, it still trails Claude's Sonnet 4.6. But the most alarming miss is in abstract reasoning. This is the big one.
On the ARC AGI2 benchmark, Gemini 3.1 Pro scored a 76.5. Muse Spark scored a 42.5.
That is an enormous delta.
Wait. It scored a 42.5 against a 76.5 in abstract reasoning. If it's so brilliant at medical triage, how does it fail so spectacularly at abstract reasoning?
It sounds contradictory, I know.
Isn't an AI that can't reason abstractly basically just a very confident parrot? How can we trust it with complex tools if it struggles there?
That is the exact tension at the heart of modern AI development. You have to understand the underlying mechanism of why it fails there. Building an AI is essentially a game of trade-offs.
Okay, what kind of trade-offs?
Well, Muse Spark is heavily optimized for pattern matching against massive corpuses of training data. When it takes the health bench test, it is drawing upon millions of medical journals and clinical guidelines it has ingested.
Right, it's seen it all before. Exactly. It recognizes the complex patterns of symptoms and diagnoses perfectly, but the ARC AGI benchmark tests something entirely different. It tests spatial and logic puzzles that the AI has never seen before.
Oh, I see.
It requires the AI to deduce a completely novel rule on the fly.
Like those visual grid puzzles where colors move in a sequence and you have to guess the next frame?
Precisely. Muse Spark's current architecture looks at that novel puzzle and frantically searches its internal database for a manual that explains it.
And there's no manual.
Right. When it can't find one, it struggles. It can't currently invent abstract rules from scratch. It can only retrieve and combine existing ones.
Got it.
So it is exceptionally intelligent in specialized data-rich domains like health or code, but its intelligence remains somewhat rigid when forced into entirely unseen abstract scenarios.
So it's brilliant at executing the incredibly complex jobs it was trained for, but it freezes if you ask it to invent a completely new job on the spot.
That's a great summary.
And the sheer cost of trying to fix those gaps, to push that generalized abstract reasoning higher, leads us to Meta's most controversial decision on Slide 7.
A huge strategic pivot.
This is a fundamental departure from the company's DNA, because unlike the celebrated Open Llama models, Muse Spark is closed. It's totally proprietary.
Which shocked a lot of people in the industry.
Right. So why the shift? The internal reasoning points to three things. First, a post-Llama 4 market reassessment. Second, commercial viability enabling API monetization and enterprise licensing to sustainably fund R&D.
Which is very expensive R&D.
Very. And third, competitive parity, to match Google and OpenAI on their own terms. Note that future models may eventually be open-sourced, but for now, proprietary is the play.
It's a complete lockdown.
So what does this all mean? It reminds me of an indie band that always gave their music away to fans for free, right? And then suddenly they put up a massive paywall the moment they built a stadium. Does this betray the developer community?
This raises an important question about the brutal commercial realities of artificial intelligence at this scale. It is very easy to romanticize the open source ethos.
For sure.
But the reality of developing frontier superintelligence is that it requires data centers the size of small cities. We are talking about facilities that pull gigawatts of power, requiring dedicated energy grids.
Yeah, the physical infrastructure is insane.
You simply cannot fund that level of physical infrastructure on developer goodwill alone. Giving away software that costs the energy output of a small country to train is just not a sustainable business model.
It's a harsh reality, but the math doesn't lie.
Exactly. If Meta intends to actually defeat OpenAI and Google, they need a robust monetization engine. API access and premium enterprise licensing for a closed model is currently the only proven mechanism to fund the next generation of compute.
Okay, so if Meta is locking this model down to make money, what is the immediate real-world value to the audience? Like, why should you, the listener, care? So we revisit that health bench hard win over GPT 5.4. But we have to contextualize the scale here. Muse Spark is embedded in platforms used by over 3 billion people.
It's an unprecedented surface area.
The document calls this a potential public health infrastructure moment because the example they use is providing credible, nuanced health guidance accessible via WhatsApp to a first-generation smartphone user in a rural area.
The scale of that impact is profound. We are looking at the sudden democratization of leading clinical AI.
Which is huge for places without doctors.
Exactly. For hundreds of millions of people, access to a human doctor is a severe logistical or financial luxury. If the AI running natively on the messaging app they already use to talk to their family can accurately evaluate symptoms or flag dangerous medication interactions.
Or guide them through emergency first aid.
Right. It transcends being a software feature. It becomes a literal lifeline. It's not just a benchmark, it's public health infrastructure.
It's an incredible vision. But hold on. Deploying clinical medical reasoning to 3 billion people on WhatsApp sounds amazing until the AI hallucinates a diagnosis.
The risk is definitely there.
Right. Even a tiny failure rate, when spread across 3 billion daily active users, translates to millions of wrong, potentially dangerous medical instructions being sent out. Are we really ready for that?
The stakes are incredibly high, and clinical hallucination is the single biggest barrier to entry. But you have to weigh the risk of the AI making an error against the baseline reality of those rural users right now.
We do what?
For many, that baseline reality is zero access to any medical guidance at all, or reliance on local, unverified misinformation. The goal right now isn't to deploy an infallible AI doctor. The goal is to deploy an AI triage system that is statistically much safer and more accurate than the alternative.
That's a fair point.
But you are entirely correct. The engineering responsibility on Meta to implement strict guardrails is immense. The AI has to explicitly know when to say, I don't know this, you must seek a human hospital.
And that incredible distribution scale is exactly why Muse Spark doesn't need to win every single abstract reasoning benchmark to win the war, as Slide 9 proves.
Exactly. The true measure of Muse Spark won't be a leaderboard. It is adoption.
The breakdown points to unmatched integration. 3.2 billion daily active users. No rival can match this surface area. And radical accessibility, no paywall barriers for core features on Meta.ai today.
It's an aggressive strategy.
This creates massive competitive pressure on OpenAI, Google, and Anthropic. It reminds me of the streaming wars. You can have the best, most critically acclaimed show on a niche app, but if your rival's app is already installed on every TV in the world for free, the rival wins. Distribution is everything.
It's a flawless comparison. Putting a frontier model directly into the hands of billions overnight forces the entire industry to accelerate their innovation cycles. Google and OpenAI can't just rest on their abstract reasoning scores anymore.
So with this new giant fully awake, Slide 10 shows us exactly where Meta is stepping next. Muse Spark is just the first step on the scaling ladder.
Yeah, they're not slowing down.
Not at all. The roadmap outlines the now phase, which is the Meta.ai launch. The near term is the social ecosystem and glasses rollout. But the midterm points to the Hyperion data center, which is scaling compute for the next iteration.
A massive infrastructure play.
And long term, they hint at a potential open source release once they're contesting AI dominance. So looking at this massive scaling effort, it leaves me with one final provocative thought for all of you to mull over.
I'm curious where you're going with this.
Well, if Meta's Hyperion data center successfully turns WhatsApp, Instagram, and smart glasses into the world's primary, highest functioning AI interfaces, will we eventually stop visiting traditional websites or search engines altogether?
Oh, that's a heavy question.
Right. What happens to the internet when one social media giant becomes our only required portal for reasoning, health, and discovery? Something to think about. Thank you all so much for joining us for this deep dive.